Okay, welcome everyone to episode 7 of Learning Live with AWS and HashiCorp. My name is Cole Morrison, and I'm here with my awesome streaming partner from AWS, who I will let introduce herself.
Hi there, I'm Jenna Pedersen. I'm a developer advocate for AWS. Happy to be here.
Yeah, it's been quite the journey over the past couple months. I know that I've learned a lot. We've gone through a lot, and welcome everyone in the audience. Please chime in. Ask some questions. Tell us where you're from. Just interact. I will say we do have like sort of some giveaway stuff that we can do if you're interested in swag. Anyone who does any awesome participation, as long as you're connected to Jen or I, we might send you something. So that'd be cool. And then I also think we have a survey again for this last episode, which if you want to tell a little bit about that.
Yeah, so we've been doing, this is our 7th episode, and we do this every episode. We want to make sure that we're getting feedback from you, both on the show that we're doing, each of these episodes, and the content that we're sharing and how we're doing as we present it. But also, we want feedback on our products and services, both AWS and HashiCorp. And so this survey, it's an opportunity for you to share your feedback and your input on what we're doing across a number of different things. And for the first 20 people, I believe today, that fill out this survey. If you haven't done this specific survey for the show before, you'll get a $20 AWS credit code. So we'll show that off about halfway through, and then again towards the end. So stick around, and we'd love your feedback.
Yes, absolutely. So for those of you who are joining us from the first time, and hello everyone, we've got some people tuning in from Vegas and Austin. I am out in LA, so near the Pasadena area, and Jenna can tell where she wants to if she's from.
Yeah, I am in St. Paul, Minnesota.
Yeah. Right, so if you're just turning in for the first time, this series here, what we've been doing over the past episodes is creating a microservices architecture on Amazon ECS with Terraform, Consul, containers, Docker, quite a few different technologies. And the first iteration we did was without a service mesh, and we just did it how one might take that approach. And then what we did for the second half of the series is we work it to use Consul as a service mesh. And obviously this is one of many approaches. There are many ways, and that's easy to forget when you find that one solution, but there are a lot of different ways to implement what we have done. This is just one way. In fact, I'd love to hear your thoughts on that, Jenna.
Yeah, I mean, we're gonna talk kind of about we're gonna do a huge recap at the end, and talk about some of the different choices that we have to make and the pros and cons of this architecture. And so we showed one option during these 6 or 7 episodes now, and so we'll kind of share a little bit more about that later on too.
Yeah, that'll be great. Just so that's obviously for time, we want to make sure we get through the key parts. So speaking of which, again, before I hop into this, I'm going to show you all some images so that I can use less words. If at any point you have questions, curiosities, please feel free to ask. And if something doesn't make sense, of course, reach out as well. But I just wanted to give us what we're going to do here today does require a little bit, a small upfront understanding of where we've come from and where we're going to, so that we can really understand the problem. Because I found it interesting in conversation with Jenna the other day. We were going through this demo, and towards the end, she was like, well, so what is the exact problem we're solving? And I was like, oh crap, we should probably define that better. So let me go ahead and share my screen here, and hopefully this diagram is visible. Is it visible?
Yep, I see it.
Yeah, perfect. This is what we created in the first part of the series, right? You have a client service that is reachable from the internet, that reaches out to a fruits and vegetable service that ultimately reach up to a database. We spent the first 3 episodes, I believe, getting this created and all of the infrastructure around it. What we did for the second part is we swapped out these pieces to use Consul and turn it into a service mesh. Now, there's a lot of concepts that we're not going to go back and recover here. If you are interested in hearing about how service mesh works and how specifically how it works with Consul, please check out our previous episodes. And in fact, Jenna put together a bit.ly link that I can put up on the screen here for the past episodes. If you want to go check those out, go and be sure to do that. So basically what's happened is we've gone from sending everything to load balancers to their associated service to giving all of our services sidecars. So kind of like chips to the sandwich, where the sandwich is the service, the chips are the Consul client that accompanies them. And they all start talking to each other through the Consul client. It's very, it's comparable in what we did in episode 4 to being in a house and having a delivery person do all your external communications for you. If you have delivery people handling all of those, well, then you control the delivery service. You can figure out how many messages are going about. You can secure them, all sorts of other stuff. But I don't want to get too deep back into that description there. And Jenna, if you have any thoughts there, please.
Well, I always like your analogies. The chips to the sandwich. That's a great way of describing this.
Nice. I guess I'm hungry, right? Yeah. But architecture aside, that's great. But what does this mean for us as an individual contributor, someone working on this stuff day to day? What are we trying to make for us, right? What is our stuff today? What we're trying to do is set up a workflow, right? And what is our workflow right now? What we can do right now is we can develop locally. We can push that up to a GitHub or get any type of version control system you want. But when we want that infrastructure to deploy, well, we got to bring it back down on someone's computer and run Terraform apply, right? And that's how we've been doing it. It's been working. But what do you see there in terms of issues, Jenna?
Yeah, I mean, the first one that I see is what happens when there's more than just one developer on the team. So right now, it's just been me and my local laptop, and I've been Terraform applying. And I mean, we've learned that Terraform stores the state of our infrastructure in I can't remember what file it is, but it's on my local laptop. And so if Cole goes and wants to run this in the same area against the same infrastructure, that's the right word.
That is.
We gotta figure out a way to solve that problem.
Yeah, and it's messy right now because if what'll happen is if Jenna runs a Terraform apply, she will create. And by the way, the file is just called a state file. I know it's very creative. It will go and make
state. Is that the name of it?
Yeah, literally, it's a state file. It's such a plain name. That's why it's so easy to forget. But what I would have to do, let's say that she's like, hey, we need to change. Cole, can you like update a security group? If I were to pull down just the code, so if I were just to pull this down and run Terraform apply without communicating with her at all, I would actually create an entirely different infrastructure because I do not have her state file, nor do I have the variables that she may have passed in. So that is a problem. What I would have to do for this to work is I would have to basically take the setup on her local machine, so her state file, the variables that she passed to it, and any other things, probably her AWS credentials too, to make sure that I'm in the same account. I'd have to pull those down, and then I could run Terraform apply. And that's just with 2 people. You add 3, 4, 5, 100, you're probably going to go insane, right?
Right.
So, as Jenna pointed out, there are the problems, more people. There's also, how do we test if changes are valid? Who's going to do that? Just because I say that my plan worked, that doesn't mean it will, right? There's separate environments, right? And there's also just some bonus stuff, just like code checking. And what about blue-green deployments, Canary rollouts, different stuff like that. So to talk about what we're going to head towards today, we're going to upgrade our workflow in a few aspects. The first one we're going to do is we're going to get into Terraform Cloud to help us solve this first bit of developing with multiple people and pushing to multiple environments. We're going to make it so that multiple users can develop on one GitHub repo, which you're going to see Jenna and I do. But from that single Git repo, we are going to manage multiple different infrastructure environments. And so we have here on the diagram, we have this concept of workspaces, and don't worry, we will go into that here shortly. So don't think about them too much. But the way that you can think of what is going to happen here is Terraform Cloud is going to hook up to each of these Git to this Git repo, and it's going to be as if they all make 3 different local machines. And on each of these local machines, they have their own state file and their own variables that we pass, and they all run Terraform apply, and that is the equivalent of making those 3 different infrastructures. So you can kind of think of it like that. And if that wasn't crystal clear, we will go into it a bit more. So that's part 1. Any thoughts on that, Jenna?
Not yet, no.
Cool. And yes, as a question, no S3 backend? No, we will not use S3 backend, although that's absolutely an option, and it can work. There are plenty of people that just do these full pipelines by themselves. We're going to get it done with Terraform Cloud. And this is something I don't think a lot of people know. It's kind of odd, but it is free for the first 5 people. And if you're on a modern engineering or tech team, you're probably not going to extend that much more past 5 people. Perhaps you've got a few more, but how many people are going to be on the infrastructure? My point being is I know for a fact with this particular thing, we wanted to make it to just be really cool for Terraform users to solve the problems you're going to encounter right when you go past 1 or 2 people. Anywho, so that's what we're going to do in this first bit. We're going to hook up Terraform Cloud, and then we're going to upgrade it 2 more times. The second thing we're going to do here is add Sentinel checks. So this answers the question of, well, code may go up, but how do we know it's secure code? How do we know code didn't leave an S3 bucket open, right? That would be terrible, right? And this is going to give us another check that we're going to be able to add in places. It's going to be something we're going to do with Terraform Cloud. Yes. And then last but not least, we are going to take one more look at the end on what about managing Consul clusters that are live with Terraform. Well, that's something we're going to do as well. And we're going to use the same workflow that we're going to learn here at the beginning to make it so that we can write Terraform code that will update a live Consul cluster in one of these different environments. So yeah, a lot of stuff there. The reason I wanted to bring this up here was because, again, if you are tuning in for the first time, this is going to be something you can use. It's applicable and it's useful to you. If you have a Terraform project, this is going to show you how to set it up for multiple people. And if you have a live Consul deployment somewhere, this will show you how to work with Terraform to work with Consul. Okay, now that I have just run my mouth for I don't know how long, Jenna, do you have any thoughts? Or you can even poke fun at my diagrams here, like anything.
No, I like these diagrams. I think, like you said, a picture is worth 1,000 words. I just want to, before we move on, I do want to mention we have a couple of AWS and HashiCorp people in the chat today. Darko Ricardo from AWS, and I see Rosemary in there from HashiCorp. I'm not sure if there's anyone else, but say hi to them. They're there to help you with questions. They'll drop some links out as we talk through things. So if you have questions, please ask them in the chat. We'll try and answer them live as we're going through. But if it doesn't make sense for us, one of them can help point you in the right direction as well. Yeah, I think that's all I wanted to say.
Perfect. No, that's good. You keep on point with keeping me to remember that there is an audience here.
Yeah, staring at the wall.
Yeah, I very much appreciate that. So now, before we get deep into hooking and setting all of this stuff up, for this all to make sense, this is going to begin with Terraform Cloud here. And so because of that, I do need to give a bit of an overview for all of it to make sense. And this is kind of coming from the fact when I tried to talk through this by myself, I was like, I'm basically just producing gibberish right now. I should probably think about this a little bit more. So so let's talk about Terraform Cloud in general. But let's not get too lost in what it is. What it is, in a nutshell, in a very roasted, simple nutshell, is a hosted service that's going to run our Terraform apply command for us. Yeah, we're going to need certain we'll create variables, credentials, and get the correct providers and pull down. It does a lot of these other things as well, but you can kind of sum it up in that original analogy we talked about, where it is like having something make machines for you that then set up variables and state files and run Terraform apply for you. Right now, of course, we're doing that on Jenna's machine. And while that's serving our purpose, the first time someone else has to update it, we're going to encounter those problems. Well, it would be better if we had a remote machine or a remote environment to set all of this up. And again, that is what Terraform Cloud gives us. At least that's the most immediate problem solved. We'll obviously see some more stuff here later that'll allow us to open up more collaborative opportunities. But what we're going to have set up here is make it so that we're going to quit running Terraform Apply entirely in our own machines and manage all of that from Terraform Cloud. Now, there's a lot of other things that it does, but let's get into some basic concepts that you need to know, because otherwise when we show the UI, it's going to be like, yo, what's going on here? So there's a good deal of them, but at first, in terms of signing up for Terraform Cloud, we have some basic stuff to know just around users, accounts, teams, and organizations, which there is nothing too crazy here, right? Much like how AWS works, we have our users that belong to many organizations and teams, and an organization is more or less just a top-level organizing concept that controls billing, and users can join. Since a user can join multiple organizations, it means that even though Jenna and I are part of a single organization right now where we're going to set up our project, we could also belong to other ones, and we won't be paying our organization well. So that's the simple stuff, but I feel like I got to get that out of the way, because otherwise it's like, well, who do I join? What do I do there? What questions can I look through here? Let's see. Looks like we've got some comments, and Jenna, if you have any stuff too or thoughts on other questions, please let me know.
Yeah. There's one of the questions from, I think, Abhishek. I saw one more approach is using exporting environment variables. How different is that? And I believe this was in reference to when we were talking about sharing our code and our state, rather than as opposed to using Terraform Cloud, or as opposed to sharing it potentially up to S3. So I'm not sure if that's actually an option or not.
Yeah. If Abhishek, if you could clarify perhaps a little. Okay, sharing states in separate environments. Sharing states in separate environments. By environments, do you mean separate like developers, or separate like entirely different infrastructures? Just here, let me go ahead and give my my answer based on my current understanding. In terms of the problem that we have here that I think that is being communicated, the first one is exporting environment variables. Rosemary chimed in with which I think she believes is the question, referencing exported TF variables or environment variables. So in a Terraform project, when you apply it, you have outputs, and those outputs are values from that project. You can bring those outputs into other Terraform workspaces, other environments, if you need to build atop those, if that is what you're asking. Now, the reason I asked for a bit more clarification, because sharing states in separate environments, if the environment you're talking about is like staging or production or a live infrastructure, you would not share a state between those. Those would all have their own state file if we're going on that. So hopefully that answers it.
Yeah.
Cool. Was there another question that I missed?
There was another question. This is one we're going to actually get to, but from Christian Perk, where would you save the TF state? And so,
right.
In this case, it's going to be, and you correct me if I'm wrong here, this is going to be stored in Terraform Cloud when we start using Terraform Cloud. Right now, it's in my local machine. It's not even committed to my Git repository.
Right. Exactly. Yeah, we'll be using Terraform Cloud as opposed to the other option, just because it's going to handle, one of the very simple things it's going to handle for you is just locking. So just the whole concept of a mutex. If you're storing in an S3 bucket, you're going to have to set up a custom control to lock that if two people are trying to access it at the same time. right? Because obviously, if you're both trying to make changes simultaneously, you can create problems. Well, that's just a very simple thing that you get right out of the box with Terraform Cloud. Anyhow, hopefully this very boring initial part makes sense, right? You just have organizations, you have users which are separate from them that can belong to many of them, that have teams and many workspaces. So nothing that we really need to know more beyond that. The main unit we need to talk about is the workspace.
Yeah.
So this is where you do and get a lot of your stuff done here with respect to Terraform here. So far we've only used our Terraform project to deploy one infrastructure environment. It's almost as if the code on Jenna's machine maps directly to the infrastructure itself. But it's not the actual HCL code. No, instead, whenever we do a Terraform apply, a state file is created. It keeps track of all the live resources that have been deployed. And also recall that our Terraform apply took into account any variables that we passed to it. So just to give an idea of what this looks like, to understand the way the state file works, that we can understand the significance of state files a bit better, if we wanted to use the code Jenna has right now to deploy a new infrastructure environment, what would I have to do? What would this look like in plain vanilla Terraform? Well, this is basically what this looks like. With our Terraform code, right, we have plus variables, any type of different variables, 2 different variable sets. When we run a Terraform apply, this creates a state file. Technically, the state file is created very plain right at the beginning when you do an init, but this updates the state file to make it unique, and that deploys a separate infrastructure environment that we'll call A, right? But if you change that, if you put this on someone else's machine, it is going to create an entirely different state file. And hopefully this points out that if we wanted to collaborate, right, we would have to do that, pulling down the same code, making our machines the same. But Terraform Workspaces solve that by, when we create that stuff up there, these different workspaces are going to handle all of these different differences for us. And with that one Git repo, we will be able to easily create these without having to literally set up separate machines or pull them down onto different, into different environments. Kind of lost my words there, Jenna. Did any of that make sense?
Yes, no, that all makes sense. Yeah, I'm just looking at the diagram here. Yeah, so it looks like we've got our code, which is mapping to one workspace labeled A, named A here. Mm-hmm. That workspace, whenever we want to, is that bottom workspace supposed to be A or B?
It's supposed to be B. That's just,
Okay. I was like, why is there 2 workspace A's as I started talking? And then I was talking it through. And okay, so there's amazing. 2 workspaces. And so the way I was trying to kind of understand the concept of a workspace here is, to me, it's like an environment. I've got a production environment, environment A, or I've got a staging environment, environment B. There's a little bit more to it there, but as we're going to see as we get into this, but conceptually, high level, that is how I'm kind of making it work in my mind.
Yeah, and I can kind of, apologies for not changing this letter A. That did make that a bit more complicated. In essence, what we're setting up is one GitHub repo maps to different infrastructures. We map to those different infrastructures by making different workspaces. And in each of those workspaces, they have their own variables and their own state file. So hopefully that's good there. So let me hop this back up, and I actually don't need my screen on here anymore. That's all of the images for now. Now I can actually see myself in the chat instead of talking into the oblivion. Just to make sure, did I miss any questions here?
I don't think so. I think we're just clarifying a few things. Oh, yeah, I think we've got it all cleared up.
Yeah, cool. So all of this begins, and I know if any of this sounded complicated, just know it's the novelty of it. But as soon as we get in here and we start setting stuff up, it'll make sense, because it's pretty simple. Now, this all begins with signing up to Terraform Cloud. We have done that already because it's very easy. We want you to sign up for it. Just like signing up for AWS is very easy too. So we're not going to show that. Instead, what we've done in the background, and I will post something if you do want a step-by-step. So let me go ahead and post this in here. This is a step-by-step from our wonderful Learn team that will show you how to sign up to Terraform Cloud if you need more in-depth help. But what we've done in the background is Jenna's created a Terraform Cloud user. We've created an organization that's going to house all of our workspaces, and both Jenna and I have both joined that. And so we're all under the same organization there. And Jenna, I was wondering, can we show your screen? Would you mind showing the Terraform Cloud console to everyone? Keep saying console.
Yeah, I gotta log in really quick.
Yeah, all good. Just tell me when.
Yep. It logged me out apparently.
Yeah. And
okay.
Welcome from Brazil. We're up here in North America. Welcome everyone, really.
Yeah,
okay, so
thank you all for being here. There are a lot of people from around the world today, and it's fun to see where everyone is tuning in from. So thank you. Okay, I'm good to go on.
This comment right here.
Yep.
Okay, so here we are in Terraform Cloud. We are both in the same. Oh, would you click on that? Well, I guess this is where we'll be able to talk about it. This is the main area with
exactly.
Workspaces.
This is where I've logged into.
Yes, but Jenna should be a part of two different organizations, which is that drop down up there, and we're going to go to my organization, so the J. Cole Morrison one. And on this one, we have unlimited power. We have the best type of account where we can do everything.
Yep.
So yes, so that's the first thing. You want to make sure that you're there. But the next step here is we're gonna now make some. We looked at the organizations. You would change those organizations up in the top left. And then workspaces were in that area, and then the settings are exactly what you think it's going to be. Just a lot of different settings for your account in general in context of this organization. Yeah, there's actually not a lot to look at without any workspaces. So let's just go ahead and get to it. So the first thing we need to do here to get hooked up to Terraform Cloud is make some changes to our actual code. So I'm going to put up the banner to our working GitHub repo that Jenna's been working on. So we'll go ahead and show this here. The first thing we need to do is tell Terraform that we are going to be using a different location to store state file instead of our local machine. So we can do that by going into our main.tf file. And right there under that Terraform block, we are going to add a new block, a cloud block. And this is going to be how we're going to tell Terraform that, hey, we're going to be on Terraform Cloud. And we're also going to need to tell it the organization that it's going to be a part of, that we're going to be pushing our workspace and doing our work in. And then also, we're going to add something called a workspace tag. So any workspaces we create wind up getting this tag so that if we have a ton of workspaces, we have a little bit more organization. So Jenna is going through here and she's making some variables to hold our stuff. Now, if you've worked with Terraform Cloud before, we are using the new backend here, the cloud backend. Some of you may be familiar with the remote backend. It was our old way that you hooked up with Terraform Cloud. This new cloud block, though, makes it a bit more seamless, and we're improving on it and adding more features. So yes. So I did see a question. Are Terraform workspaces, are they the same as namespaces in Kubernetes? No, they are not. I'm sure someone could draw an analogy to them, but I probably wouldn't go with that. Again, a workspace is just a separate state file and separate set of variables. Okay, so there's that. Let's add those variables to our variables file now. So that
okay.
And we're going to leave those without a default value because we want to force people to input these. And then while you add those, I'm going to answer this question. Is there a way to handle errors without deleting or rerunning it? So deleting or rerunning it, are we talking about Terraform, and what type of errors are you speaking of? So like when a plan fails, when an apply fails, if you wouldn't mind elaborating. Apologies, it's not showing your name, LinkedIn user. I'm sure that's not your actual real name, but that's what it's showing. Yes. Okay, so what we're doing here for this block, these two placeholders, is again, we have to tell Terraform Cloud what organization we're going to be working in. and then also what tags we want in any new workspaces. Now, that said, when working with Terraform Cloud, there are a number of approaches that you can take to this. You can work with it from the user interface. You can work with it through the command line interface nowadays. Oh, and you can work with it directly through the API itself. We're going to be doing a mix of the different things, though I will say our probably more seamless workflow at the moment is going to be using the user interface, because it's the one where we've put in the most work. And the command line interface workflow, while that has some convenience, the difficulties with it is you still have to run it from someone's local machine, or you're writing a script to do it on some remote machine, at which point you may as well just use Terraform Cloud. It obviously has its places and its utility, but it's something that we are rapidly improving on. So, okay. So to follow up with that question, so showing handling errors without deleting and rerunning it when an apply fails. This is a very good question, and the truth of the matter is the hard part with the Terraform apply is there are some errors we cannot catch until after we go up and try it on the live infrastructure. There's just certain things we're not going to know. So like something that I ran into the other day was not being able to provision IPv6 on my VPC. And it turned out that the error was because I have a different type, I have some different availability zones enabled in my account that don't support it. That error, there's no real way for me to catch that until the apply tells me. And then after the fact, you can rerun it and it will try and pick up where it left off. But sometimes you do have to delete it. So that's a good question. And if anyone has any other information around that, please chime in. Okay. Sorry. So I will get to some more questions here, but I do want to watch for time here and stick with Jenna here. So we've got those variables created.
I got my variables in here.
Cool. So let's go ahead. Why don't we do this from a CLI perspective at first, so you can see it. It's going to be the same thing, but we may as well. The first thing let's do is let's into your terraform.tf vars file, that one that we have get ignored. Let's add 2 more variables to it, and yeah, and also you can delete the console server allowed cider blocks went all together. Yeah, and I know this is going to sound silly, but we probably aren't going to need any of those, but just leave them in there for now. So let's go ahead and head over to your command line interface once those are saved. Yep, and let's run a Terraform init. Yes. And this is going to say, oh, hey, variables not allowed here, organization. Okay, well, that's fine. You know what we can do here is we can leave those there. And what we're going to do is we're going to go set them up in the UI. So let's just do this. Let's go up to Terraform Cloud. Yep. And so what we're going to do now to get this all hooked up, I was going to show the setup there, but it can be a little odd because the backend's looking for an organization name and a tag, but oddly enough, the command's not directly necessarily tied to that code. So let's just ignore that for now. What we're going to do here, so we've got that code. Let's actually push that code up to the main branch. Let's make those changes and push them up to the main branch.
Okay, so we know that I don't fully understand why that's not why those variables aren't allowed. Yeah. But we know that it's not this code, right?
Yeah, right. It's to be honest, I ran into this issue last time. We can put those in there, but the reason why I don't want to necessarily hard code those in there is simply because if you wanted to use this for a different organization or different tag, we want to make sure that those are set there. We will set those in the variables for our workspace, so it should work out there. And if it doesn't, we'll pivot. Yay the joys of live coding, right? And I know this is bad. Yeah, just push it straight to main. Like we're gonna go rogue today on this.
Oh my gosh. Okay.
Perfect. So it's on main. So now we're configured to do that. Let's go back over to Terraform Cloud. And to answer some questions, just some questions from people here. Is it possible to use TerraTest in Terraform Cloud? With our new run tasks feature that we added, it may be, but I actually don't have an answer for you on that. I can get back to you. If anyone else in the chat knows, that would be great. Is that error scenario, if they mismatch, not something the linter could catch? It is not, and it's because it was an experimental feature that was enabled that isn't necessarily going to show up. It just occurred when you tried to grab availability zones that are beyond the normal ones. And the code that catches it is actually in our repo. So if you want to check out our data.tf file in there, you can see where that's handled. But no, it is not something that is in our code. It's something that could only be caught when the deploy starts happening. Okay, apologies. So let's click on plus new workspace here. Yes. And so what we're going to do here is choose the version control workflow. So you just click the top one there. And we're going to connect to GitHub, yep, there we go. And we're going to click that first repo right there. As far as the workspace name, we do need to think about the name of it. Why don't we just name it? The reason I want to make the workspace name shorter is because certain things like IAM roles and the like have a character limit. And if it's too long, it'll just fail. So that kind of goes back to the previous question. That's a thing that Terraform will not cut you off, and it will let it try to go and apply, but then AWS will return it. But
sure.
Let's see here. We've got a shorter tag we could use. It's not the prettiest tag, but it is short. I can just send it to you if you want to do that. If you have any better naming conventions, please feel free. And then I'll answer some questions while you do this. Can a workspace call multiple repos at the same time or just one repo? You can set it up to work and call to other workspaces serially. You can also set it up to be to look in separate directories and trigger on those. But in general, we just keep one repo per workspace is generally the recommendation. Same with modules. Okay, so as for these settings, description we can leave as is. Let's add a tag to the end of that one. Let's call this LLAWS. So we're just learning live AWS and HashiCorp. And let's add -staging to it because we're going to make a staging
for the name.
Yeah, for the workspace name. Apologies.
Got it.
Yeah, and then for the Terraform working directory, that'll just default to there. We'll see for the apply method, we can see that we can make it wait after a plan, or we can make it automatic. Let's keep it manual.
Okay.
As far as triggering runs, we do want it to always trigger a run to do a plan there. So apologies under the pull requests. This is just going to trigger a run when anything changes as opposed to a particular path in the GitHub repo. And this actually goes back to that previous person's question. This is how you could have a repo with multiple submodules and then trigger on those submodules. You could use that option there. Yes, click that option for pull requests. We'll get to see that an option. And then we'll leave the submodules on clone alone. And then we'll click create. Yeah. So there we go. So it's going to do all of that. So let's go to our workspace overview. Oh, here we go. You know what? Just leave this. We're gonna just do things manually instead of following the wizard. So just go to workspace overview.
Okay.
Yeah. So there is this. We have a couple other things that we need to do here to get this set up. But let's go ahead and make a second workspace first, just so we can see how we're connecting things. So go back to workspaces, and we're going to create another new one. And we are going to same flow, same connection. And then just that first one, obviously. And the only thing we'll do is change that name to -prod, so for production. And so to go back to that analogy, it is as if Jen is going up here and making two separate machines that are going to pull down our code and run Terraform apply. It is the easiest analogy and way to kind of digest it. And yep, all that looks good. Perfect. Now we can go to workspace overview. And let's head back to our workspaces and click on the staging one. And we're going to do some stuff here to get this set up. So the first thing we're going to do is click on the settings. Yep, and then we're going to, oh wait, no, we've actually already connected it, just kidding. So the next thing we're gonna do is go to variables. So that little variables tab. And this is where you would, this is the setting stuff in here is the equivalent to making a variables file, right? Or running Terraform apply and filling those in. These are what are going to carry over here. Now, there are some variables that we do need to add. There's the ones that we've specified in our variables file that are marked as required, but we also need some environment variables. We need a way to reach out to AWS. So let's handle the simple ones first. Let's add that TFC organization and the TFC workspace tag of variables here. So we can just click add new variable. Yeah.
Okay.
Yeah. And then just name it as you would like. So not as you'd like, the names that we made for those two new variables.
What we did in our code?
Yeah. Yep, right there, the TFC organization and the TFC workspace. I think that may have failed because we didn't set a default value, but either way, this still is a bit cleaner because this way we're doing the full UI approach instead of the CLI approach. And then for this workspace tag, let's just give it in quotes, in double quotes, that LL AWS HC thing, just so we know these will all belong to each other. And you can click the HCL thing there. Yep. And then just save the variable. And then we need to do this one more time with the organization. Yep. And then while you fill that in, yeah, just that J. Cole Moore's in lowercase. If you didn't want to do these piece by piece here, and we're going to look at some options here in just a second, what you could do is you could make a .auto.tfvars file, and any file that ends in .auto.tfvars will be brought in as workspace variables. The problem with doing that, though, is if you push out your code repo, it means any workspace created from it is going to automatically have those variables set. Now, for these, that's useful. There is the way that we're doing this here, which is, kind of a way, but it can be a bit, we got to go input these everywhere. But we can also use variable sets. So why don't we go up to, we can see those down here. Let's go up to settings.
This settings or this one?
Yeah, the top level settings.
Okay.
Yep. And then down to variable sets, which is under organization settings. Yep. And so the way that these work is for your different workspaces, we can create generalized variable sets here and then just apply them to the different workspaces as we see fit. So what we see one here, which are actually Jenna's AWS access keys that we're going to apply to our workspace so that it can authenticate with AWS. But why don't we go ahead and make another variable set and call it these TFC like defaults or something. Yeah, let's call it TFC defaults. Yeah. And we'll just leave the description as is. For our workspaces, let's select those two workspaces. Well, we can add them after the fact. I think it's just lagging. But just go down to variables and add variables. And I hate to do this, but will you add those exact same two variables again? Yeah. And there's one more you can add too, and that can be your EC2 key pair, the EC2 pair variable that we do need as well. And that way, because we know we're going to need that in all of them, this way we can just apply this variable set as opposed to doing these piecemeal. Yes. Question, can TFC pull secrets from GitHub secrets? Probably, I would imagine through a run task, you probably could, which is a new feature. I don't know that we'll have time to get into today. And I know through Sentinel, you'll be able to, because there's an HTTP import that you can use to reach out and do something there. But in terms of like pulling them in as variables, I'm sure there's a workflow. I don't have one on hand though. But if you want to follow up with me, I'm sure I can find someone who knows that answer. Sweet.
Okay, got all three of those added.
Perfect. Now just click create variable set. Perfect. So now we've got that. Let's go back to our workspaces.
Should we go? Is there some, like, do we need to fix this?
We can do it from there. all this is going to do is just apply it from here as opposed to us applying it under the workspace. We can probably just refresh. That might let us do it.
Oh, too late now. Let's do it over here.
Yeah.
Okay.
So
what you're saying, variables? Okay. We'll do it from here instead.
Let's delete those two. I know you did them. I just wanted to show it.
You just wanted to see me type.
That too.
I'm not doing as much typing this episode, so
a lot more clicking, right?
Yep, that's okay.
So let's apply both variable sets. So first, let's do the TFC. Yeah, there's that one, and then we will apply the next one. And there we go. So we've got those. Note that in these two different variable sets, we see category is Terraform, and those are for direct Terraform variables, but there's also env. So whenever Terraform Workspace runs an apply, it's going to do that in an environment, and we can set environment variables. And so two that we have set from this variable set are the access key ID and the secret access ID. Cool. So there is that. Let's do this. Let's go up and actually see this in action. Will you head up to actions, that drop down there on the right, and click start a new run. And let's just call this just initial run or whatever you want to call it. And let's click the drop down, and let's just do a plan only, just to see what's up, and start a run. And this will do our first run. And so this is the equivalent of Jenna set up a new machine. She has set up the variables for it, and now she's triggered a Terraform plan. So this is going to run, and we will see what happens here. If it fails, it's because I'm trying to mix the CLI workflow with the with the UI one.
That's okay.
No valid credential source for AWS provider found. So we scroll down here just so I can't see the. Okay, so it is just so generally this error will pop up if our credentials aren't correct. We probably shouldn't do this on screen, but can we check the names of the? I think we just have to look for typos here, because that's what this is.
Where what am I checking the names of? Should I look at this provider in the main file?
Oh, no. This is gonna basically what's happening is the provider is trying to authenticate with AWS, and it's saying it can't find any credentials to do so. So let's go back to our variables. Yep. And so we have access key ID. I think the secret access key is just called secret access key and not secret access key ID. So let me unshare your screen here real quick so you can go and edit that in the variable sets. But yeah.
Do I just have to edit it in the variable sets? I don't have to go. Do I have to reapply it or anything?
I don't think so. It should update automatically.
And you're telling me it should be named
let me double check. Let me confirm here. I'm pretty sure it should just be. So there's the access key ID, and then there's the secret access key, but no ID. I'll just.
And they both start with AWS, or they don't?
Yep, they do. Let me send you the exact examples there.
Yes, great.
I just slacked them to you. Yeah, I always forget this too. One's ID, one's not. They both have key. They both have access. It's easy to get lost in it. But once you edit those should be update across all the things. Yes, someone just put that in there.
AWS access key ID.
Yep. Let's hope that is our only error, right? Because that's an easy one. But yeah, so while she's
when I set these up, I totally was trying to copy what I had.
Yeah, that's what I do
before, but I didn't do it right. Do I need to put quotes around that and make it HCL or no?
No. Since it's environment, yeah, you should.
It is an environment variable.
Yep.
Okay.
And then can Workspace, I'm just going to answer some questions. Yep. Can Workspace variables be shared with other workspaces? Yes, as outputs, they can be shared as outputs, or you can share them by making a common variable set, much like how Jenna's doing here. If you really want the same ones in all of them, though, you can just make a file, and I'll just, let me just type out what that would look like here. It would look like any name auto.tfrs. I just typed that in the chat there for LinkedIn. I'll type it in the other twos. Any file that you have in your Git repo that's named like so will be picked up by the workspace and assume that those are variable values that you want. But that's only if you want them in all of them. So you gotta make sure, and you also gotta make sure you want to commit it to Git. Okay. So our
I think we're good.
Can I share your screen again?
Yep, you can. Yeah, that's what I mean.
Yeah, sure.
So I went back to my workspace.
Yep.
And it does look like it's reflecting the right
sweet
key now.
Well, let's go up and trigger a new run now. So start a new run. Let's do just a plan. And this will go into there and run it. And while this runs, answer question. You always have to use access keys and secret keys for Terraform Cloud, correct? You don't use assume roles. You can actually use assume roles for Terraform Cloud. In fact, for when I'm playing in Terraform Cloud, I'm actually using a role. But just know that whenever you assume a role, simple token service or secure token service, whatever AWS calls it, they return back access keys and secret keys, an access key ID and a secret key for that role, even if it's temporary. So you would still grab those values from the role and input them here. Of course, the pain with that is roles are generally temporary in time scope, so you'd have to refresh them constantly. But yeah, you can still indeed use roles. Cool. So thank you for the question, Joe, by the way. So this is going through here and it's starting up a plan. And while it does that, why don't we head over to our, it just finished. Sweet. And the nice thing about this is, yes, the log output we do in terminal is great, but when you look through the Terraform Cloud here, we can see what resources are being created, what provider they're from, very over the top. And what else do you see in here that interests you, Jenna?
Well, I mean, this is kind of nice. The cost estimation of what I just spun up.
It is. Yeah, that is nice. And here we can see when we're doing a data source, which is the arrows, that means it's gone and fetched something. So.
Oh, you mean, sorry, one of these here? Okay.
Yep. Yeah, so that's where, and the diff's not found because I don't think we've run it before, so it can't diff anything if we haven't done it. Yeah. So cool. So that's good. Let's go down. I think that's all I think we can just leave this screen now. Yep, we can just leave this screen. So let's go back all the way to the top and head into our workspaces again. And let's go to the production one. Yep. And let's go to variables and apply both of those as well. So apply those two variable sets. So we've got those, great. And then the next one, and we should be good. And for just for some other questions here, for secret protection, do you use assume roles to connect to AWS account? There's a lot of answers for that. Jenna, if you have anything on it, feel free to go in on it.
I don't right now.
Okay, yeah. You can use assume roles to connect to accounts, but obviously an account with the ability to do it has to be able to issue that to you. Our plans version in TFC, for every plan, you will be able to access, for every run you do, you'll be able to go back and look at those. And would you be able to show how the assume role was done? Probably not in this one. I don't think we're going to have the time. And then rollback capability in Terraform Cloud. We can talk. I think we'll be able to talk about that here later on. Tell me if I forget to touch on it, but just for time's sake, we should move through here. So these are all set up. Unless I miss something, we should be able to start another run as well.
Okay.
Yeah, I'm going to start a new run and then just call this, and it'll do the same thing. So, yep, that is it. So to round up our analogy here of what has happened, right? What we did so far, We pulled down our Git repo. We modified it to tell the Git the Terraform code. We're going to be working with Terraform Cloud. We're going to be working with this organization that we'll put in a variable. And then Jenna pushed that code up, and then we set up 2 different workspaces on Terraform Cloud and connected them to GitHub. If you want a very easy analogy, chat, it is as if Jenna just went up Terraform Cloud, made 2 different machines, and on each of those machines set her variables and connected them to the Git repo to pull down and run a plan, which is what we've done on both of those. So even though they're sharing the same code base, they're operating in a different parallel universe. Okay, that was okay. Yeah. So that'll do its plan. We can actually just go to Workspaces, the just main Workspaces screen, because when that is successful, we should see. But if we're good with staging, let's go ahead and apply it. Let's go ahead into staging here, and under Actions, click Start a New Run, and let's do a full plan and apply. And this is how we're going to do set this all this infrastructure up. Yeah. Now, let's, as this goes through and applies, we did make some changes to the code in the background between the last episode and this episode. Some very small changes. They were mainly just set up for working with Terraform Cloud. But one of the main things we did is set up a service intention in our Consul deployment. If you recall from the previous episode, we launched, once we got Consul set up, we had it so that all services were denied talking to each other by default. And we had to go into the user interface and set up intentions to allow them to talk to each other. The main code change we did was just setting those up in the code so that it happens automatically as opposed to us doing it in the user interface. Cool. All right, Jenna. So it's been a blast. You've been clicking like crazy. What do you think of stuff so far?
I'm ready to see it like actually created.
Yeah.
We're still planning, it looks like.
Yes.
Oh, here we go. It's gonna go.
Okay. Nice. And then now we've got the apply pending. So sweet. So now all we would have to do is someone come in and click confirm and apply. So
right. And so this is a manual confirm and apply. I have to actually press the button because of how we set this workspace up. There are two radio button options. One where it automatically just happens, and then this option, the manual.
Yep.
So
exactly.
I press it.
Yep.
Okay.
And let's hope.
The standard comment.
Yeah. So yeah, now it's going to go and apply, and we're going to be able to see all of that here. And of course, this is going to be different from what happens in the production one. The production one isn't running at all. And so hopefully the workflow here is kind of making sense because we've already set ourselves up for these multiple infrastructure environments. Right now, what happens is the next time we push a change to main, it's going to trigger one of these runs in both this workspace and the production one, and it's going to sit at that plan bit. And the way that it would look like is Jenna would come in here, approve staging, then we'd go and test it, and then we'd go to production, approve production, and then be good to go, right? So that's already a workflow we've got set up. And I know that took us a little bit of time, but I think that's because we were trying to be good and remember our audience and answer good questions, which there's been a lot of good questions, by the way.
Yeah, there has been.
Yeah, for Jenna, today is click day instead of usual super keyboard day.
Yeah.
Yeah, I remember way back when there was this tool you could use on Mac called like mouse keyboard cat or something like that, and it was this tool that would help you get rid of your mouse altogether and like fly around the screen just using the keyboard. It was like VI for UI. It was very weird, but
that's cool.
Yeah, I never got it really working, but it had a cat as a logo, so I was a fan. Yeah, cool. Great. So this is applying all of our infrastructure. This is going to take a little bit of time, but as this goes down through here, we can scroll through those logs, through the logs that it's outputting, and it's going to show us all the specific IDs for these different resources that it's putting into our state file, and it is making the state file.
Could I actually go into my AWS console and take a look?
Yeah, go for it.
I mean, just since I know there's a cluster that's created.
Yeah.
I
We'll
should
see
see
that
my
it's all.
staging cluster.
Mm-hmm.
Nothing interesting happening yet, but that's created. Okay.
Yep. So
Wanted to
it'll
see
keep
where we're
going
at.
there. And then I'm just going to answer this question real quick. What would be the right way to handle multi-account environment deployment with Terraform Cloud, TGW attachment in Workspace A, and TGW route table entries in Workspace B? I'm assuming you mean by that having your infrastructure component like broken down into components as opposed to like the full thing in one bit, and that all set over multiple accounts. Do you mean multiple accounts in AWS or multiple Terraform Cloud accounts? If you wouldn't mind elaborating. Yes. So this is always going to take a few. Again, this is the Terraform break. This is where you go, you get your coffee or your tea or whatever it is that you're drinking, and watch things happen for you. And but just to give for to show what's up next, although it just finished, so we're good. Nice. That was relatively fast.
Where did you see that finished?
Oh, it just turned green.
Oh, the whole thing turned green.
The whole bar. Yeah.
Okay.
So let's head down to the bottom. I'll loop back to the question that LinkedIn user asked. I need to see the names here. That Jonathan P asked, yes, because I can see their name on LinkedIn. I just can't see it in my streaming thing here in a second. But I do want to show something here. So if you'll click on apply finished, so just open that thing all the way up and go all the way down. We're going to see two things here. If you'll click on outputs, that little gray banner thing, this is going to show our outputs. So why don't we go ahead and open up both the console server endpoint and the client ALB in a new tab. So we'll just go ahead and open both of those. And for this question, Canary, blue, green, we are actually going to see how to do some of that here at the end. Although we're kind of seeing blue-green right now with the infrastructure if you're testing your whole infrastructure, but obviously blue-greening for apps or Canary deployment for the apps themselves, you'll see. So for that services thing, the reason you're getting a 503 is because the services are still standing up, so those will come up.
Okay.
But I'm going to unshare your screen, but you see that state version created right down there? Don't click on that just yet, but you're going to click on that link after I unshare your screen, and in there, it's going to be your state file. And one of those outputs is going to be that bootstrap token. Just copy it. Oh, sorry.
Okay. Oh, this here. I click on that. Yep.
Yeah. Let me unshare your screen though.
Okay.
So, there we go. Yeah. And then just grab that token, and that's what we'll use to log in to the Consul UI. Oops. Yep. Take your time.
Oh my gosh. Sorry. It's one password is getting in the way. Okay.
Cool. Got it?
Nope.
And then,
yeah,
close that state file if you wouldn't mind. Yeah. Good?
Good to go.
Okay, cool. So what Jenna did is she just, on every run, you get to see the state file after that run, which is what Jenna just looked at. And in that state file, it's going to have all the outputs, all the values. And one of those things was that sensitive bootstrap token. And she just grabbed that and logged into Consul. So let's head over to Consul here. We'll see that it looks like everything is now green. Let's head over to your 503 tab and refresh it. And we should see, yes. So we see everything is working. Great.
Cool.
Yeah, nice. If we go to services, let's go back to services, if you wouldn't mind, and click on intentions, the intention side. Yep, we'll see that those got set up for us instead of us having to come in here and do them manually.
Right.
Sweet. Okay, so at this point, we are very much set up. We could go to our prod workspace and deploy that infrastructure if we wanted to. It would deploy it to an entirely different set of resources, and we'd have two separate environments. And then if we're done with staging, we could just get rid of it. But in terms of testing updates to infrastructure, and of course, what about working with other people? Well, what we're going to do is we have decided at our produce tech company here, that Fruits needs an overhaul. We need a version 2. We are going to break all the things. We're going to just mess up the whole API. Every developer out there is going to hate us, but we're going to love it. So,
but we're actually going to maintain some backwards compatibility because we'll have both services out there, V1 and V2.
That's right, because Jenna is lawful good, whereas Cole is chaotic neutral. So so what I'm going to do here is, as she has added me as a collaborator on this repo, and I'm going to submit a pull. Well, first up, I'm going to merge her changes. So let me go ahead and do this. Let me go ahead and grab those changes and merge them in.
Do we need to apply all this in production? Oh,
we
wait.
Could. Sorry, go ahead.
No, go ahead.
We don't have to. Again, it's just like another machine ready to go.
Yeah.
When we want to deploy it and make a production one, we could, but and we can maybe at the end if you want to. But let me push this up real quick. So git named this like the longest, this branch like the longest thing ever. Okay, so I'm gonna send you a pull request, Jenna. And will you head to our repo?
Yeah.
And show the pull request? So, oh, nice. Yeah. And we'll see here, we refresh, actually click on show all checks down there under the all checks have passed. Oh, okay. Maybe refresh here. Okay. I think it's because we haven't run one for the first time. That should be triggering a Terraform cloud check. Huh. I wonder why that's not doing that. Interesting.
Is it because our other stuff is in the main branch?
No, this on every PR should result in a speculative Terraform plan that should pop up under here and show that. I'm curious as to why that's not triggering here.
Is that because we have it set up in our Terraform cloud connected to this repository?
I think it's because I have not. I think it's because it doesn't explicitly have those workspace tags and everything set into it. Which what will happen is after I merge this in, I'm pretty sure anything else checked out and used with it would trigger a PR. But just for time's sake, we'll move on. It's not the biggest deal.
Okay.
But what will happen is generally a speculative plan will occur here, and you will see whether or not it passes or succeeds. But I'm unsure as to why that has skipped, but that is just how live demos go, right? So let's go ahead and merge the pull request. Actually, let's not merge it. Let's look at the files change.
Yeah, let's see what we actually changed.
Yeah. So we just added some new logs for our Fruits versions 2. That's all that the first file is. And then in the subsequent files, we've added an entirely new ECS service called Fruits version 2. And then we've added a new cast definition called Fruits version 2. Now, for this demo's purposes, it is literally just a copy and paste, and I've just appended hyphen version 2. So those are the only differences here. But if this were a true different service, then the underlying Docker image, we would probably have changed and retagged and pushed up to Docker, and we would use that. So let's assume this is good, and go ahead and merge that PR. And when we do this, let's hop back over to Terraform Cloud and go back to our workspaces. Just go to the top level just so we can see. And we'll see here that 2 plans got queued.
Okay.
So now they're running them both, and they're going to sit there after that plan. And this is where we can incrementally improve them. So we would go into staging, let it finish its plan, and you would say yay or nay. And if yay, we would test it on staging, and then afterwards we would go to production and release it there. So, and here's our history of our runs, where at any one of those you could go back to track the state file at that part if you wanted. Yep. So this is going to deploy that new service. Now you may be asking, well, that's a new service, but we're not using it. And this is true. We aren't using it yet. And that's because we haven't told Consul about the new service or how to do that. But while that happens, we get through this. Yes. So this goes back to a Techie Thoughts ask here. Can we use patterns like Canary, blue-green, using Terraform Cloud? Well, you're kind of seeing here to an extent how we're doing a blue-green on the infrastructure itself. Now, setting up a Canary to the different infrastructure endpoints at large, that would probably require us going up a level, working with DNS, something like Route 53, and splitting based on that. So we're not going to go that high level in blue-green. And by the way, it looks like that finished. Feel free to confirm and apply it. Yep. And then after you confirm it, you can just go to our console UI, console, and click on services. And once it's done, we'll see the V2 one pop up here.
Okay.
Yeah. But it goes back to the question about using patterns like Canary. When that gets brought up, generally probably asking about the application itself. So we've got this application in here, and now we want to split traffic between Fruits and Fruits version 2, which we will see pop up eventually. Well, those aren't actual things we need to change to our infrastructure. These are changes that we need to make to Consul itself. So I got to do some talking here, which is that we can kind of fits a thing. But before I get into this next part, with what we've just done there, Jenna, what do you think about it? What do you think about this with respect to the problems that we talked about at the beginning and all that jazz?
Yeah, I mean, I like that some of this work is taken off of my laptop and is pushed up to the cloud, up to Terraform Cloud, and it's all managed there. I do like the idea of right now we're just working in the one workspace, but I do like the idea of having these two workspaces, staging environment, production environment. I'm now able to go, it's applied, so I can go in and make sure that everything is working. It's looking nice. I can actually run smoke tests on the staging environment if I want before I actually apply it to production. But it's all ready for me. Like that plan already happened. All I have to do is go in and click that button.
Mm-hmm. Yeah.
But we're not going to do that yet.
Yeah. We could, but yeah, we'll just leave it as is. Yeah, so that solves the infrastructure problem for the most part. You can make a ton of workspaces. If you wanted one for just development, you can make a new workspace, follow these exact same steps, and we'd be good, right?
Yeah, so that makes me ask this question. So as a developer, would I have my own workspace for Jenna and you have yours own for Cole? And then we have our staging environment, or how does that work?
It's a very, very good question.
And the answer is it depends.
Yeah. That is a very good question, right? Because if you're developing a feature for development, do you want an entire development environment set for it, right? Or do perhaps you want to set up something like Docker Compose locally and then just have maybe a common development environment where you test? I mean, there's a lot of stuff that you could do, but that option is open to you now. If you wanted to do that, you could create a separate workspace just to make those changes. So to give an example of how that might look, you would create a new workspace called Jenna's Development. You would go to our service and change out fake service with like a new tag Docker image or whatever updated Docker image, and you'd be able to test it there.
Okay.
But yeah, that's a good question. There are a lot of different ways you could do that. So
yeah.
Any other thoughts from chat or yourself on that would be awesome, but not required, obviously. So, okay. On to the next part. We need to split to Fruits version 2. This is mission critical. We must go to the version 2 of Fruits. We've set up the workflow for the infrastructure itself, but it's not covering the Consul cluster. Consul cluster is live. Yes, we can do some stuff from the user interface, but those changes aren't going to last if we tear down the infrastructure. We stand it back up, right? We would have to reissue those UI commands or the CLI commands. Also, we could manage Consul from just the command line interface, either locally or on the servers themselves or with Bastion, but those still don't persist. So we need a way to make these configuration changes persist and also be stood back up if something goes down. And since we're in Terraform, why not stick with Terraform and use the Consul provider? Much like we're using the AWS provider to let us do this. That's what we're going to do. But before we get into the implementation, let's talk about the end result that we're trying to achieve here. We've just added this new service, V2, and we want to start rolling out parts of the traffic to it while still keeping some of the traffic on our original V1 fruit service. That way, if V2 doesn't work, we aren't upsetting everyone. Now, if you've set this up before, really on any cloud provider, there's quite a bit you have to do. There's a lot of pieces and a lot of automation. And if we think back to our discussion on service mesh at the beginning, we asked, well, what's an alternative? Well, that alternative is a lot of automation. So that's what we'd have to do to set that up. But with Consul as a service mesh, we're actually going to see that something like a Canary rollout and split traffic can be done very easily. Now, there are a couple concepts that we should hit to make for all of this to make sense. So let me share my screen one more time. And that will all probably, hopefully, be the one more time. Let me put it on here. Okay. And let me open back my stuff up here. So the thing to know about Consul, when you go to update it, you can update it through the CLI or the user interface. That is one way. But the other way is you can create config files like we have shown in the example here and give those to the Consul API. When you give them to the Consul API, whether that is through the CLI itself, the user interface, or just directly through the HTTP API, these configurations take place across the entire cluster. Now, this is a lot like Kubernetes, kind of. It's kind of an analogy, right? You have your YAML files, you post them to the control plane, and they go and they make everything happen. Well, that is very similar to the way that this works as well. So generally, you're going to create a series of configs. You're going to write them into Consul, and that's how that's going to happen. So let me unshare my screen here. That was what an example config looks like, but we actually have an example. Jenna, would you mind going to our repo and then into server.sh, the server.sh file?
Is this our main repo?
Yeah. Apologies. Yeah, and then all the way at the bottom in that configuration file, from lines 84 to 110, we can see where we've set up some of these configs to happen on Bootstrap. So this is where we've done those here. The problem with doing them on Bootstrap is like we couldn't just edit this and it worked because these only get recognized the first time the Consul cluster comes up. And we want to keep it up as much as possible.
Yeah.
Okay. So thank you for showing that. I'm lost in my number of windows here. But how do we do this with Consul and Terraform, right? That's a question. Well, it's probably best to just walk through the steps. What we're going to do is we're going to make a new code base in a new Git repo, and in it, it's going to be its own code base in Git repo, and it's going to have all of our Consul configurations in it, where we're going to write these configurations in Terraform code. And then we're going to do the exact same workflow we have set up for the other repo that we have. We're going to create two different workspaces, and both of these workspaces are going to map to their associated staging and production one. Obviously, this is how we're going to see how to move values between workspaces, because that was a question asked earlier, and also what you'll have to do if you're working with sensitive values. But this is also the flow that we're going to take. Okay, so let me go back here. Let me put Jenna's screen back on. Would you mind navigating to our Consul config repo? Yes, you've got it. So this is the repo that we've set up. We went ahead and set it up in the background just for time's sake. And there's not too much going on in here. The first thing in main.tf that I wanted to show is just that we've got the usual setup that we had for the other one with the cloud block, but we're using two different providers here. The first one is TFE, and that is our Terraform cloud provider. And this one is what's going to allow us, much like how the AWS provider lets us get data about AWS, this is going to let us, for example, look at our workspaces, look at their outputs, and use those in this project. And then the second one is Consul, the Consul provider. And this is going to let us hand it a live Consul cluster and interact with it through. And so we can see down here, we've configured the Consul provider. We didn't need to configure the TFE one with anything because that's good. So now, beyond that, if you will go up to the top level of the files, there is the console config.tf file. And it's in here that we've written 2 new console configs. One, the second one, which I should have put first, but the second one, is a service intention. And it is all that this is saying, hey, it's a type of service intention, and we are going to allow the client to access our Fruits version 2. That's all it's saying in a nutshell. And I have many a doc in terms of how to write these that I will post later on. But at the top here, we have the actual splitter config. And the splitter config saying it's a service splitter. We have all sorts of different kinds of configs that you can write. This is just one of these other different types. And it's going to be for our Fruit service. The name corresponds to this service, which is on line 3. And then lines 5 through 14 are how we're just splitting it. We're splitting 90% to the default one, and then we're splitting 10% to this version 2 one. And so all
this on line 3 indicates the default.
Well, okay. Yeah. That's just if you don't specify service and next to that wait one, it will just default to that service name. Yeah,
that makes sense.
And that long garbled stuff of data.tfe outputs, this is saying go to Terraform Cloud, go to the workspace we've specified, look at its output values, and get me its project tag output. And this is how we'll put those out throughout there. Okay. So there is that. Sorry, did you have any thoughts on that?
Nope, that all makes sense to me so far.
Cool. So let's head back over to Terraform Cloud.
Okay.
Yep, and we are going to play the same game here of creating a new workspace. And same flow here. Connect it to GitHub. We're going to do the console one this time. And advanced options, everything. Yeah. Yep. Let's do that and create the workspace. I wonder if it didn't save the checkbox in the other one. I wonder if that's what did it. But anyhow, let's go to Workspace Overview, back to the Workspace Overview where we'll do stuff there. And let's go to variables. And we're going to need to apply those 2 variable sets that we already have. Granted, we don't need your EC2 key pair for these, but it's not going to be used for anything, so it should be fine. Right. So, and would you mind going back to that repo, the original console repo there, and going to variables just because I forget which ones we need to set, to be honest. Workspace. Oh, so we need to set the TFC workspace. So we do need to create a variable for that. And this is just what workspace is it trying to manage the console cluster for? And in our case, it's going to be that LL AWS HC staging one. So let's go back to Terraform Cloud and make a new variable with that name and with that key. And we'll make it a Terraform variable and just, perfect. And then click HCL and we're good. And then the next one is the tricky one that I'm going to have you do off screen. We need the console token. And that's exactly what you think. It's the one you use to log in here. We just need to set that as a sensitive HCL variable right there. So I'm going to remove your screen share so you can do
environment or a Terraform variable.
Yep, Terraform variable. And this is what it's going to use to make changes to console in the background. Now, if you wanted to, instead of using the root token, you could generate another token with limited permissions. However, if your intention is to manage the console cluster as a whole, you're going to need one with a lot of powers to do so. Anyways, though, it would be better practice to scope that down to an admin token.
And I'm using the token from the other run, right?
Oh, yeah. Sorry. Yeah, from the most recent run on the staging one. Yeah. Which shouldn't change. Like that would only change if the console servers went down and came back up.
Okay.
Yeah. And again, chat, if you have any questions, please feel free. And for those who may just be joining in, what we're doing is we have a Git repo that I will post up in the banner. We are tackling the problem of how do we take one set of infrastructure as code and map it to multiple infrastructure environments, right, without duplicating it, and how to collaborate with other people. We've set this all up on Terraform Cloud. We've gotten past that. We've now got blue-green almost with our infrastructure set up, and we're dealing with a Canary deployment through Consul with Terraform and Terraform Cloud as well. Okay, are you ready?
Yep.
Let me reshare. Perfect. So we've got those variables in there. TFC workspace, our defaults. I think we're good to go. Let's go up to scroll up to the top here, and we should be good to do a run. Yeah, I think we connected the Git repo. So let's start a run. Let's actually just, let's just do a full-blown plan and apply.
I'm hoping that I put quotes around that Consul token.
Oh, yeah, I know oh yeah, you did. You did need quotes.
I do. I know I need it. I just can't remember if I did it or not.
There we are.
Yep, okay, right, so will you just unshare that really quick?
Yeah, for sure. The old double quote problem.
Yep.
Okay. So again, just to show to understand the workflow for anyone who's just tuning in, we are seeking to manage our Consul cluster with Terraform code. And in order to manage the Consul cluster from Terraform code, it needs to be able to authenticate with it. And to authenticate it, it needs a token. And so Jen is grabbing the token that was generated from our previous workspace and inserting it as a variable in the next workspace. So we've actually, now that I go back, we've actually seen a number of different ways to connect outputs and variables between workspaces. Yeah, we can just ignore it. That's because we have that in the variable set.
Okay.
Way number one was this manual way, just grabbing the values, inserting those variables. Another way was the auto.tfrs file. And then also was that TFE provider that we saw in the code base that has reached out and grabbed everything. So it looks like stuff's good. Let's go ahead and confirm and apply it and hope that it works. So if this works, go over to our Consul UI and click on intentions. When this is done, we will see this, should see this new intention pop up, and then we'll be able to see the 90. So there it goes. Let's go back to our run. Looks like it's finished. Awesome. So let's go to our client application load balancer right there. Okay, so we see here how we have hello from the Fruits client. Our new Fruit client is not going to say that. It's going to say something different. And right now, 10% of our traffic is going to go to it. So now let's start pressing refresh until we, there we go. So here we go. Part of it's going to version 2. And if we just keep refreshing, we will see that the traffic is now split, right? So that's pretty neat. And eventually it'll go back to 2. And so that is that. There's our Canary rollout, which is pretty neat.
There we go.
Right? Yeah. If we wanted to do this for production, what we would have to do is the exact same steps that we've done for that workspace, except renaming them. Do you want to do those, or do you think we should move on?
I think we should move on. I think it's exactly the same, right?
Yeah, it's the exact same. It's literally the only difference will be grabbing the token from the production run and then setting the TFC workspace variable to the production one. Those are the only differences. Yeah, so there's our Canary deployment. Like, I wish I could make fireworks pop out, because in the past when I tried to set these up, it was, it's a very difficult process, because now the question of would you mind going to the Consul repo? Apologies. Yeah, and then go up to the top level directory and then into Consul config. Let's say that we are done and we haven't approved this. I could come to this repo, submit a PR that changes these weights, push it up to Terraform Cloud, or not push it up to Terraform Cloud, merge it in once Jenna approves of it, and Terraform Cloud would run it, and we would have the new splits. And we're done.
Right.
Pretty cool. Pretty simple.
Cool.
Yeah. Nice. Well, it was one of those things where it's like, it took us so long to put this together, but we just set it all in 5 minutes. So
yep. And it looked like, when we look in here, it's like, oh, yep, there it is. There's not, you don't see very much, but yeah.
That's why you show this to non-tech people, and they're like, okay. All right. So we are almost there. There is one more thing I wanted to show, and this is going to be the quickest one, because it's literally going to be one box and we're going to be good. The final thing to look at here is the flow of checking our code after we've done a plan. So this is what happens if I submit some code that opens up an S3 bucket to the world. Nothing in here is going to stop that, right? Nothing's going to stop it because it's a valid plan, it's a valid apply, it's a valid rule in AWS. And most, we might get a tiny warning return, maybe if we're lucky. But the most likely scenario is Jenna and I will be on the front of Hacker News as an S3 breach, and that'll be fun, right?
We don't want that.
Yeah, right. So what we're going to do is we're going to look at doing some automated checks on our code when it comes in. Now, here's the thing. Before applying, although we've got a human right now that will always take a look at this plan, they're not necessarily going to catch everything. And what happens if we want to make this a purely automated process? Well, if that's the case, we better have a darn good way to check for insecure changes. Right. Well, if I told you you could check our incoming Terraform code, what would you say if we could watch for what we consider bad configurations? Well, that's actually what HashiCorp Sentinel does. So let me share my screen one more time. And actually, let me find, I meant to pull up the Sentinel website. We'll just pull up this one. Here we go, the Sentinel website. And this is a policy as code framework. And so what do I mean by policy as code? That means we write code that watches our Terraform code and either says yes or no. It's that simple. It's very, what I will say about it is going to come in just a second because I'm not going to go off key because that's how I get scatterbrained. So let me go back to my slides here. So what Sentinel does here is it inserts another step in between our plan and apply. In this step, we have code, Sentinel code, that we can write to check things. So it can check a lot of things. It can check our plan. It can check our configs themselves. It can check the state file, and can even check the data coming in for a current ongoing run, And the way that it works is that when Terraform Cloud reaches this Sentinel step, it passes the data about that run, so all this data, so the plan, config, blah, 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 to Sentinel. And with that data in mind, we can write a series of rules that will either pass or fail. If they pass, hey, it'll do a Terraform apply. We'll go up to AWS. If it fails, well, we're done. And we don't have as much time to cover this today, so we're going to do this one a little bit quicker, but it doesn't really need a lot. So let me reshare Jenna's screen. Would you mind heading over to that Sentinel repo? Yes.
Already there.
Nice. Winning. So this is the way that you create a policy to guard things is that you create a Git repo. And in that Git repo, you create Sentinel code. So if we have our main.sentinel HCL, and this is where we're going to bring in our Sentinel code itself, we're bringing in some helpers, and then we're defining a policy. And the policy is what actually gets checked. If you'll hop back up to the main level, the TF plan helpers, if you'll click into it, we'll see here at the top, we're doing some imports. So we see TF plan, strings, types. TF plan, when we say that, is going to pull in the plan from our current run and let us look through it. You can ignore the rest of this file. It's just helper functions. So,
okay.
Yeah. And then if we head back into the require VPC DNS host names, what this is going to do is pull in those helpers, look at our VPC, which is shown on line 9, and then it's going to see if it has on lines 14 and 17, or 15 and 17, if we have the enable DNS support options set to true. If those are both set to true, we will be validated and it will pass. If they're not set to true, it will fail and we will be sad. Now, to use this, this is very simple. Let's head back over to Terraform Cloud and into settings on our purple navigation bar. So all the way at the top, let's go to policy sets, connect the new policy set, and play this fun game of connecting to GitHub, which, yep, so nothing new here. You can leave it as that. And then why don't we just do 2 specific workspaces? So we'll just click on the selected ones and then just select our staging and production one. So add workspace. Yep, perfect. And then connect policy set. Perfect. Now let's head back over to our workspace, into the staging one, and then just trigger a plan. We'll just do a plan just to see it here. You just do a plan and just say whatever you want to call this. Yep, that's actually very good. I like that. And we'll go into the run and we'll see a new step down here at the bottom, policy check pending. So this is going to queue up a plan. It's going to cost estimate, and then we're going to see if our infrastructure passes this new policy. Spoiler alert, it's going to pass because we have those enabled, but yeah.
Okay. Now, I like this.
While that, yeah, it's good controls. Now, I will say with Sentinel, to understand it, what happens here, the way that this looks is Sentinel does have its own programming language, which I can post. Sentinel. Here are the main docs that I've just put up in chat. Are these the main docs or these are the crappy ones? Okay, no, these are the main docs. I'm putting in both LinkedIn and our other platforms. It is its own programming language. And the way that it works is when it gets to the policy check, it's going to hand you basically a series of maps or objects or whatever you call them in your given programming language, hash tables, it doesn't matter. It returns all that data there, and you're able to look through all of it and return true or false based on what you see there. In a nutshell, that's what you do with Sentinel. It gives you a lot of power. There's a lot of built-in imports that you can use. So we have stuff. So for example, if you want to reach out to an HTTP service to check through one of those, maybe send some values up to check there. It has, all of the other basics like working with strings and other different types. So everything you need is in there. It is somewhat of its own learning experience because it is its own programming language. So you will have to go through that, but with that comes a lot of power. But in terms of using a policy, Jen has shown the whole workflow. You commit it to a Git repo, you follow that format, you connect the Git repo in your Terraform Cloud account, and you just apply it to the workspaces you want. And then we reached the end.
We've got a policy check passed.
Yeah. Sweet. So that's that. So now we have created that initial, let me show it here, that initial workflow. Too bad I don't know how to use my mouse. Here we go. That initial workflow, we finally have this all set up. We've got it so that we have multiple workspaces, all mapping to different environments, all going through Sentinel. And then, of course, we also have the Consul one set up as well. And so hopefully this diagram makes a little bit more sense. It makes an update that updates the Consul cluster with, in our example that we did with the staging one. So there's that.
Cool.
Okay, that actually brings us to the end of all of the demo stuff that we had today. My goodness, there was a lot. Thank you for clicking through all of that, and thanks chat for all the conversation and stuff.
Really good questions.
Yeah. So before we move on from what we've got here, obviously we can delete stuff and clean it up. But what are your thoughts on the workflows we just did there around both Sentinel and then also like managing Consul from Terraform?
Yeah, I mean, I like the idea of Sentinel, especially if if I am like, let's see, what would I be doing here? Pretend I'm creating a new workspace and advanced options. This is what I'm looking for here. Like I'm not going to check auto apply here unless I have some level of validation and verification happening on the actual infrastructure. And so that's where Sentinel comes in, right?
Yeah. You nailed it. Dead on.
I know. Yeah. And I know there were a couple questions in chat about, I think there were some other, like TerraTest was one thing that someone brought up. And there's other ways to do infrastructure testing. Are there ways to hook into that to add in addition to Sentinel, or is Sentinel kind of a replacement of that?
It's a very good question. So we recently launched a new feature called Run Tasks. And Run Tasks, much like GitHub Actions, allow you to insert tasks to be run before or after your apply. right? And so part of those tasks can be to reach out to an HTTP service and send it your code, which it may look through that code, check it, and send it back. So you could do that. So there's always an option. There's a lot of different options around the policy as code space, but Sentinel is HashiCorp's built-in one to Terraform Cloud. That we have a team supporting and everything else. So it's it's there. I will just say the main learning curve with it is a programming language. You do have to think imperatively, which is kind of a difference in thought from Terraform, which is very declarative. But it's powerful nonetheless.
Yeah.
But yeah, what other thoughts did you have?
I think that's mostly it. I mean, one thing that like I'm still kind of wrapping my head around is the separation of this. Like we have a separate workspace, and you and I talked about this a little bit. We have a separate workspace, a separate Git repo for our Consul configuration. Can you remind me what the reason for that being separate is?
Yeah. So the reason why we have it separate, and again, this is just one approach, there are other ways, is part of it's an order of operations thing. So let's talk about the like that part, because that part's mainly it. In order to start operating and configuring and working with Consul, the Consul cluster must be live. That is the main thing. To work with a Consul provider, it needs an address and it needs a token. If we were to stuff all the code we made for this Consul repo into our current one, we would get a problem. We would get a condition, basically a race condition. It wouldn't be a race condition. What is the name of this condition? Whereby it's like, hey, Consul's not live yet, so I can't do anything with it. That's something, for anyone who's watching who's followed along with the Getting into Consul series that Rosemary and I do, is a frequent issue that you have to deal with. Is in order to do the configuration changes, you must bootstrap the cluster first. So that's probably the biggest reason. The second reason is so that we can control changes just iteratively. If it's its own separate GitHub repo, we have all of those advantages of organization, tagging, branching, being very specific around that Consul cluster. Because the thing is this, even though we're thinking an immutable infrastructure with your Consul servers, I do think in an ideal scenario, you would have that split out into its own repo as well. And we would have all of our services in their own repo all connected, mainly because with the Consul servers, you really don't want to be taking them up and down very much. So that's why we have those separated there. That all said, as we saw when we're setting this up, there is the option to, when you give a repo to Terraform Cloud, to point to a directory in the repo to trigger on. So we could keep this all in a mono repo if we wanted to, but we just aren't.
Sure. Okay, that makes sense.
That's a good question. And if anyone else has any other architecture patterns that they're following, I'd love to hear them. But we do have a tool called Consul Terraform Sync that actually gets rid of having to do this in general, where you can just add a new service to Consul and it will create all the Terraform code for you needed. So you don't even have to do that, but we don't really have time to get into that.
Yeah.
Yes. So, well, do you want to clean stuff up, I guess?
Yeah, I think before I do that, let's I'm going to share the survey and let people take that reminder. Like this feedback, it's not just about, it doesn't have to be just about like what we're talking about here today, and maybe what you want to see in future shows for either AWS or HashiCorp, but it can also be product feedback. So if you get into any of these services that we've been using during the show, and you're up against a roadblock, or something seems hard, or something is not working the way that you need it for your use case, we can take that feedback back to our teams and help them kind of understand better what your needs and feedback are. So that is how we're going to use that feedback. Again, the first 20 people who fill out the survey will get, I think it's a $25 credit code. As long as you haven't gotten one in a past episode, there's that minor restriction. So Yep, we've got the survey link up there. I'll leave that up, and then we're gonna go. You were gonna walk me through like tearing everything down, right? Oh, you're on mute.
Whoops. Yeah, so to tear stuff down, pretty simple. You're going to click on settings.
Okay.
And
I'm going to do this in all my workspaces, basically.
Yeah.
Okay.
And we're going to click on destruction and deletion. And then there's two options here. One is to destroy the workspace. One's to destroy the infrastructure. Destroying the workspace will not destroy the infrastructure. So generally, you want to destroy the infrastructure first.
That's good to know.
Let's queue the destroy plan.
Okay.
Yep. And then we're going to really make sure. Wouldn't it be funny if up next to delete blank, we just put a little copy button?
Yep.
And completely defeat the purpose of it. So now this is going to run through and queue a deletion. And then after we are done with this, if you want to get rid of the workspace, you would go back into that same page and delete it.
Okay.
So it's just complaining about that extra variable. So it looks good. So we can confirm and apply. And once we do this, since we're deleting it, all those console configurations are going to be undone.
Okay.
Yeah, but it doesn't matter because we're getting rid of stuff anyways. So
we're done. Yep.
Yeah.
Okay.
So that's done. So we can go back into settings again.
Oops,
oh, okay.
Sorry.
Oh, you're fine.
and
then just delete the workspace.
Got it. This one.
Nice. Perfect.
Okay, so now I would do the same thing for these other two as well.
Yeah.
Okay.
Yeah. And so while you're doing that, I'll just give a very short episode recap. So we hooked up our main Git repo to Terraform Cloud. We created 2 workspaces or environments for it. We deployed our infrastructure to a staging workspace and tested it. Then we did a collaborative workflow where I submitted a pull request on our infrastructure as code and then merged it in and had those changes roll out to our staging environment. And then we also looked at how to set up a Canary deployment with Consul by writing Consul configs in Terraform. And then finally, we checked out Sentinel and how to use Sentinel. Though I guess right now we are destroying and deleting stuff. I like how that option in our UI is like very scary. Like everything it's like longer. There's red everywhere.
It's obvious.
Yeah, that's true. That's true. Yeah, imagine the UI trolling you could do if you made all of the delete actions green and all of like the good actions red. Yeah. Okay. Did you have any other recap stuff just for today that you wanted to cover before? I did want to talk about some of the stuff we missed, right? That we didn't cover, and then also how to repurpose this for your own use.
Yeah, let's do that. And then I think before we wrap up, I think I would just like to talk through kind of end to end what we did during these last few. I'm going to do it really quick. The last 7 episodes. And when I do that, we'll throw up a link to the playlist on YouTube. But let's talk about like what we meant. I think the last 2 things one or two things you wanted to talk about.
Okay. Yeah. Let me, you can go ahead and apply that. I actually have a special, I forgot that I created a special link for our playlist that we should be able to use. Let me see if I can find it here. Oh, wait, of course. I know exactly where I can go look at this. It's in. Here we go. Yes. I made it. Here we go. We have a nice link for the full playlist right here that I'm posting in. Before I forget to do that. Yes. Okay. Apologies. Back to, so we've got our deletion going.
Yeah.
So let's talk about repurposing this for ourselves, because that's a big piece that can help everyone. Actually, let's talk about what we didn't cover. So there's a couple big issues that are not covered in this. The first one is, you notice we're reaching out to a database and we're pretending like it's an external database, a managed one, say like RDS. Well, that's not showing up in our console UI because we're not managing it with Consul. If you want to manage an external service, like a managed one with Consul, you have to use something called a terminating gateway, and we actually don't have time to go into that. That said, the Getting into Consul series does have that there. So if you want to watch me like sweat bullets and like trip over issues and bugs and not get it working, go check that out.
You mean you're learning how to get it working?
Yeah. Right. We have a saying that Rosemary enlightened me to, which was problem exists between keyboard and chair, and that is so much. Yeah. Anywho, that's one part, but the second part is what you as the software developer are going to be doing. Would you mind going to our code base real quick and into our task definitions?
Oh yeah.
Yeah, I just want to show them where the funny part is if you're a developer creating one of these services, you are but one line in our infrastructure. You are this Docker image. Any of these Docker images you can just pick. So right there in line 11. So what we didn't cover is if we wanted to make an update to the service, what would need to happen is we would need to change the code. Code would need to be compiled to a new Docker image, tagged with a new tag, sent up to Docker Hub or Elastic Container Repository on AWS. And then we would have to update in the infrastructure here, and then it would go out. We do not have the software dev pipeline set up. So if you wanted to do that, that's not something we have here, but it is something you would have to do if you wanted the full pipeline automated. Are there any other pieces that you thought we left out here, if you recall? I don't.
No, that was the one that, as a developer, that's the one that I'm always concerned with. So I just wanted to make sure we talked about that a little bit. I can't think of anything else.
Cool. Yeah, I mean, there's an entire universe of stuff we probably didn't approach. Yeah. But since we're on the screen, in terms of repurposing this infrastructure for yourself, there's really only 3 things you need to do with a lot of grains of salt. Grains is plural, right? Okay. The main thing is swapping out this image with your own. So swapping out these client images, these different service images with your own, and obviously renaming everything here as you see fit. Because otherwise you might have a billing application Docker image, but if you forgot to rename fruits here, it would pop up as fruits, which that'd be pretty funny, but probably not what you want.
Yeah.
The more important part is going to be ports. So we have a lot of ports here specified in security groups, in port mappings for the task definitions, for the services, and for the load balancers. That's probably where you're going to have to spend a good deal of your time reconfiguring to make this work for you. But if your applications are based in a Docker image, if you have an external database, this is mostly all set up for you to go. Instead of using our fake database, you would just point to something like an RDS endpoint, and you'd pretty much be good to go. So as far as the Terraform cloud stuff, you would do that all verbatim the exact same way. So yeah. Okay. Now, Jenna, I know that you've thought about a good recap of the series. I want to talk about that. So please go for it.
Yeah. So I just want to. So can you put up the playlist link? Yeah. So mostly I just want to kind of talk through what we've done over the course of these 7 episodes now. So we started by kind of an intro to Terraform, how to use infrastructure as code, specifically Terraform, to spin up different resources on AWS. And the very first thing we did was a big thing, and that was creating a VPC. And so there are various resources that we had to create in order to create our little cloud within AWS that kind of holds everything and keeps everything secure. And so we started with that VPC, some of those basic Terraform concepts, creating our project to do all of this. And that's the one where that's that main code repo that we've been sharing. After that, we created that first containerized service, and we hosted that on Amazon ECS. using Fargate. And so if you remember correctly, ECS it's a container orchestration service, and it just lets us define our containers in a task definition, and then we can run individual tasks, or in our case, we ran them as services, so that we can make sure that if one of our containers stopped or failed, it would that service would automatically make sure that another one would spin up. We used Fargate, which is the serverless version of ECS, which allowed us to not have to think about specific EC2 setup for our containers. We could have done this with EC2 as well. We chose Fargate to make it a little bit simpler for us. Then that next episode, I think that was episode 3, we added some additional services. We added our fruit service, our veggies service, and then we hooked up an external database service to see how all of those played within the same infrastructure setup, and how they were going to communicate together. And what we learned there was that as we added more services or more containers, we were going to have more communication challenges. So maybe we didn't have a grocery service, but if we had a grocery service, our grocery service needed to be able to talk to our fruits, and it also needed to be able to talk to our veggies. And we had to manage that communication very manually in our code. And so as that grows, that becomes a scaling problem. And that's where we introduced this concept of a service mesh, and we started setting up Consul. And this service mesh Consul was it helped us manage both the communication, but also the made sure that our connections were secure between our services. So that line of communication was not wide open to everyone. It was only each service had access to a different service based on those intentions that we set up. And then finally today, we talked about how we can manage all of this infrastructure and work more collaboratively. So like Cole and I were actually able to both work on this today using Terraform Cloud, and by having Terraform Cloud manage our state for each environment that we wanted to have set up. So like Cole mentioned earlier, what you can do after this is take those code repositories, specifically that the main one that we've been sharing all along, and tweak that to your needs. There's going to be some customization that you have to do for what you need. You're probably not going to have a fruits and a veggie service, and you're probably going to have more than 2 services or 2 or 3 services. And that kind of leads me I just want to leave you with, like, we've talked a lot about microservices throughout this whole show, and I just want to say that it's not always the answer to all your problems using this type of architecture. And so as you're building out your application, just kind of consider what problems you're trying to solve and whether microservices will actually solve those problems. So again, often you're not going to start there. It might be where you go to when you find out that your monolith is constraining you from a scaling perspective or collaboration perspective. So keep that in mind. I think that is pretty much what I have as far as a recap. There is this link here to the past episodes. And we'll have those will be up on YouTube. You'll be able to check all of them out. You can watch them on double speed so that you don't have to spend all your time with us, and you can get through get through them pretty quickly. Cole has done a really good job at putting descriptions and chapter markers in there. And so it's easy to kind of go back and forth between everything that we've been talking about.
Nice, nice. Did you want to talk about, excuse me, pros, cons of
I think we can skip that one.
Okay. Gotcha.
Yeah, we can skip that.
Yeah. The summary of it was, it depends.
Yeah.
That's
yeah,
really
exactly. The pros and cons to microservices, and like when you choose to go straight into it, or when you choose to migrate to this type of architecture. The ultimate answer is it depends. And again, like it's going to be about choosing what problem you're actually trying to solve. You're trying to get some business value out there right away and test out your idea. It might not be the right approach. If you have a team of one, it might not be the right approach. If you have one service, one container, or a very small set of services, it might not, a monolith might be a better choice. But as that grows, as you need to scale, that might be the next step that you go to.
Well said. Very well said. Well, I believe that is it. Thank you so much, everyone who showed up today. For those of you who followed along, if you hit every single episode, reach out, let me know. You ping me or Jenna on Twitter or LinkedIn or whatever, and tell us something that you learned or that you came up with. Maybe it sparked an idea. Do a good one, not just like it was cool, like a in-depth one, or maybe give us some feedback.
Yeah.
I might send you some HashiCorp swag. You never know. So
Yes. Feedback again. I would love to hear if you've hit all of them up. That's awesome. We've loved seeing recurring names and faces in chat. That's been really helpful. I was gonna say something and now I forgot, but I don't remember what it was.
Gotcha. So. I'm gonna make our faces bigger here so that we can.
Yeah. What I will say though is thank you all for joining us for this whole little bit of an experiment between HashiCorp and AWS, and really just wanting to make sure that we get you the kind of educational material that is helpful for you, demo code that works, that you can take and that you can run with. And so thank you.
Yeah, thank you very much. And get into AWS free for a year. Get into Terraform Cloud. It is free
also
forever,
free.
As long as you're under 5 people. There's really not a reason not to use it. It's just so simple to set up, as we saw. And I will have this up on YouTube, hopefully very soon after this, with all chapter markers, all of the links that I neglected to post in chat today. I will actually get those up there. And of course, pointing back to all of our other previous episodes. And thank you, Jenna. Holy crap.
Sorry, I'm going to interrupt because I just remembered. I also want to thank our moderators in chat. Thank Rosemary and Darko and Ricardo. And I think we've had Jackie and Kunal, and I hope I'm getting everybody. But we've had a number of people that have been helping out through these 7 episodes. So thank you all.
Absolutely. Yes. And I should do the same thing. Mike Donahue, Toby, you know who you are. Dio. If I'm neglecting to say your last names, because I will botch them. So I apologize. Blake Covarrubias, and then obviously, and 100% Rosemary, who without which I would not know Consul at all. So thank you so much, and everyone else. So but especially you, Jenna. Thank you so much. We started this in November last year, and hey, we're done.
Yep. Well, this is becoming the long Minnesota goodbye, where we say goodbye 5 times or 10. That's what we're known for. One of the things.
Nice.
So,
all right. Thank you, everyone.
Right. Yeah, thank you. Bye-bye.